All right, so the conceptual study guide and test are just going to be, just like last chapter, all it's going to be, it's not going to be actually doing the math, it's just going to be knowing what to do, what's the right strategy for the situation. Okay, so it should go pretty quick. It's not, I think of all three of the parts, it probably think would be the easiest. So we just want to enter the number corresponding to the easiest and most efficient way of solving the following equation. It's not to say it's the only way, but what's clearly the best way here? If we've got something like this, x to the fourth plus 22x squared plus 21 equals 0. Keep in mind, how many terms are there in that polynomial expression? 3. Okay, so what's that pointing us towards? No, I mean, there are 3 terms. There aren't any powers, any exponents that are 3s, but there are 3 terms. Remember which was our best choice for a situation like that? What did we do when we had 4 terms? Yeah, we factored by grouping, didn't we? So that would have been, but that's not what we do here. If we had 2 terms, we could do difference of squares, sum of cubes, or difference of cubes, right? If there were a greatest common denominator, we would certainly want to factor that out, right? But there isn't, is there? Yeah, so this is, the 3 terms means it's a quadratic form. So either we're going to factor it if that's easy, or we can use the quadratic formula, right? If we used the quadratic formula here, and we're not going to, they don't ask you to do that, but if we did, I don't want to do the whole thing. But what's A? 1. What's B? And C? Okay, it turns out this would factor more easily. What are 2 numbers that multiply to C and add to B? 21 and 1. Yeah, so we could factor this. But if we used the quadratic formula, we'd get negative b plus or minus square root b squared minus 4ac all over 2a. Yeah, good. And but now the point I want to get to, what goes out front? Normally in chapter 5 it would have been x equals, but here it's not. X squared. Yeah. Because we've got x to the 4th, which is x squared squared, and then x squared is the second term, is an x squared term, right? So if we were to do this one, we would just simplify this down to a number, 2 numbers, because we got a plus or a minus, right? And then we'd set x squared equal to both of those, and then just square root both sides, right? Okay. But we don't have to do any of that stuff. We just know that it's 7. Okay. Quadratic form. Questions on that? 3 terms, quadratic form. What about this one? Okay, does everybody buy that? Sum of cubes? Got 2 terms, so it's going to be a sum or difference, pattern, and it's a sum. And there's only one sum of cubes. There is no sum of squares. But we've got an 8x cubed plus 125. So yeah, that's going to fit the sum of cubes, isn't it? Right? Okay. So, whoops, be that guy. 4. Well, should we just check it, make sure? Yeah, it is. Okay, got it? Okay, what about this one? What's the leading coefficient of that polynomial? Good question. Is it 8 or 11, the leading coefficient? 8. Yeah, coefficient always means the number that's being multiplied by the variable. So the leading coefficient would be right there, 8. What about this? To solve for x, I would first do what? We got some choices here. What would you do there? Yeah, we put that way. What do you mean?
I don't know. You can make it as cubes.
Okay, yeah, if I could divide both sides by, or factor out a greatest common factor or something, I'd always want to try to do that. But there's no number that goes into both 64 and 27, right? So I can't do anything like that. But this does break down into a difference of cubes, doesn't it? Right, 64. And what would I get for my two quantities? I'm looking, if this is a difference of cubes, I want to be able to write this as something cubed minus something cubed. Well, what's the second part going to be? 3. Yeah, 27 is just 3 cubed. What's the first term going to be that gets cubed? What goes in there? I know some number times x, right? But what's the number going to be?
4.
4. Yeah, 4 cubed is 64. So it'd be 4x is my A, and 3 is my B, and then I just follow that pattern that we've got for difference of cubes. All right, so how do I input this then? Let's see. So
What happens to the cube that's already there?
the cube that's already there, it's, well, it goes inside the parentheses, because you see what I'm doing now is I'm cubing out that whole quantity. So I distribute the power of 3 to both the 4 and the x. Right? So we get 4 cubed times x cubed is my 64 times x cubed. Okay? All right, so we're going to then factor as a difference of cubes. So it said enter DOC next. Okay, questions? Right. Okay, to solve for x, I would first, what? What are we going to do there? Can you think of a couple reasonable choices on that one? How many terms? 3. Okay, so we got 3 terms. Any ideas? Looks like down at the bottom would be our choices, right? We could either factor as a quadratic trinomial. If so, we enter FQT, or apply the quadratic formula. How do we know which one? How do we know if it factors easily? What do you think? How do we know if that factors easily? Going back to chapter 5 stuff. Somebody, I'll start calling. Somebody won't hear. Easily. What would the magic numbers have to do if it were to factor easily? Multiply to what?
20 add to 8.
Negative 20 and add to 8. Are there two numbers that multiply to negative 20 and add to 8? Sure.
Yeah.
What? Negative 10 and 2. Yeah. That's one that could, but that one would factor okay. I could break, and if I did factor it now, and this is more for the next, for the other study guides, but if I did factor that, that's going to break up into, yeah, I've got x squared. If I unfoil this, x squared times x squared is x to the 4th, right? And then I've got my minus 10 and my plus 2. And then I could just, if I were to keep going with that, I could set each of these factors equal to 0 and solve, because I've got the product is equal to 0, right? We're solving an equation here. So by the zero product property, I could just set x squared minus 10 equal to 0. And how would I solve that? Add 10 and square root. So x would equal plus or minus the square root of 10. So there's two solutions, right? What about the other two? If I set the other factor equal to 0. Subtract 2. Good. So then x would equal plus or minus the square root of negative 2 plus or minus I times the square root of 2. Right. Okay. So we could factor it. Now, what if we didn't see that? Would it have been a tragedy? Well, let's see what happens if we. What if we put in? Oops. What if we put in? Apply the quadratic formula. Because it would work. It'd be our second best option. I think it'll get us partial credit. So, yeah, we still get 9 out of 10, right? Because it's not a bad, it'll work. It's just a little bit easier to do factor as a quadratic trinomial.
What's the difference between the trinomial and the
Trinomial just means, a polynomial means many terms, poly means many, tri means 3. So it's got 3 terms that are added together.
So, but then what about the one that's just like
Was that an option?
Yeah, or I applied quadratic formula.
Oh, yeah. Okay. So that's our best answer, though, because it does factor easily. So for 10 out of 10, that's the answer. Okay, what about this? Enter the number for the easiest, most efficient way of solving this one. What would I do first here?
No.
What do you think? It's the best thing to do first there. Yeah, absolutely. If there's a greatest common factor, let's take it out. Looks like I can factor out what?
X cubed.
X cubed, yeah. If I factor out an x cubed, this one gets really easy. So if I take out an x cubed, I'm just left with what? 11x squared plus 9. And now I've got this thing fully factored. I've got 2 factors there. If I set each of those equal to 0, when does x cubed equal 0? When x equals what? 0. Sure, if I cube root of 0 is just 0. So x equals 0 is one answer. Now what about this other side right here? If I set this equal to 0, 11x squared plus 9 equals 0. What are the steps I'd go through in order to isolate x there? Okay, subtract 9, good. Divide by 11, and then square root both sides, right? Not hard, okay? So our best answer then, for sure, is 2. Factor out greatest common factor. Okay, what about this one? How many terms?
4.
4. So what do we do? Group. Absolutely. Factor by f to solve for x first. Factor by grouping right there. QRP. There we go. Okay. Got it? Okay, what about this now? Polynomial f of x equals ax to the 5th plus a bunch of other junk, where a, b, c, d, and e are just, and f are just real numbers. Has, at most, how many real solutions? 5. How many complex solutions does this polynomial have? So real or imaginary? Yeah, a little bit too talked up. It's 5. Yeah, that's the fundamental theorem of algebra. Right? You know that for a polynomial, the degree of the polynomial tells you exactly how many complex, real or imaginary, solutions that it has. Now, what about the imaginary ones? What do you have to know about the imaginary ones? If they exist, how do they always come? Pairs. Yeah, complex conjugate pairs. So, of the 5 complex solutions, we could either have 5 real and 0 imaginary, or what would be the next option? Yeah, 3 real, 2 imaginary, or
1 real, 2 imaginary, or like 2 pairs of imaginary.
there you go, 1 real, 4 imaginary, 2 pairs. Those are my only options for that one. But the most I could have would be 5. Okay, what would you do in this case? To solve for x, what would you do first here? Yeah, good. We're going to set this equal to 0, aren't we? We want to put it into standard form. So we would add to both, there you go, add to both sides the terms 8x plus 1. Good. Okay, questions? What about this? Easiest, most efficient way of solving this one? What's the rule on this one? What do we always say about these? Yeah, I can isolate. If I can point to a single x, which I can do, then I can isolate it. Well, there's an x, right? I can point to that, so I can isolate it. Now, what are the steps I would go through in order to accomplish that? Okay, subtract 11. Good. First, we're going to subtract 11. And then, let's see. So we subtract 11. Then what? Divide by 6. Then what? Square root. Good. And then last, subtract 15. I got the x all by itself then. Right? Okay, so isolate x. What about this one? Yeah, you see that? 2 terms. So it's going to be a pattern. It's a difference, and I've got an x cubed in it. So it's a difference of cubes. What about that? Grouping. Let's make sure. Let's look at that. Let's look at that closely now. It is going to group. Okay, good. There is something else maybe we could do first. We could, it looks like, 2 goes into all those, doesn't it? Yeah. So I could factor out a 2 and divide both sides by 2, right? So I technically, now let's just see what happens. If I say factor by grouping, I'm just curious. I can't remember what I did. I think it probably gives partial credit, but let's see. Oh, makes it correct. So what happens if you put 2? Because I think that's the best answer. Let's see. Oh, I'm wrong. I should fix that. You see why that's really could be considered to be a better answer in a way? Because 2 goes into all those. Okay, I gotta fix that one.
So the best answer is 2.
I think it'd be 2 because you could divide. You could factor a 2 out of all the terms and make it a little bit easier to group. Okay, if, I'll get that fixed, but if for some reason you missed that on the test, it's up to you to tell me and I'll give you credit for it. Okay, because that's, you should get, I would give you credit for either one on the test on that one. So don't lose points when you don't need to. Okay, what about this? What would you do there for sure? Say it again? Greatest common factor. What can I factor out of both terms? X to the fourth. Yep. Good. Factor out the following. X to the fourth. Okay? All right, two more. Determine the degree of the polynomial. What's the degree? How do you know the degree? Yeah, highest power of x. Good. So it'd be 9. Okay, and last. What would we do with that one? Two terms, right? It's a difference, but does a difference of cubes work there? No, what's our other option? Yeah, well, isolate almost. That's not even an option for us right now. Next chapter it will be. We just don't know how to undo fourth powers yet. That's what we're going to study that at the beginning of chapter 7. But we got factor as a difference of squares. Now let's look at this last one just for a second here, and then we'll be done. If I were to break this up into a difference of squares, 256 is just 16 squared. What's x to the fourth squared? That's what squared? Yeah, x squared. And we know our pattern for difference of squares, a squared minus b squared factors into what? From way back chapter 5. A what? Plus b times a minus b. Yeah, so then this is just going to give us, this is going to factor into a plus b times a minus b. And then what could I do? If we were going to finish this problem up, now what could I do? Now that I've got this thing broken down to small factors, what would I do with those factors? Yeah, set them equal to 0 and solve. Yeah. So I'd get x squared plus 16 equals 0, so x squared equals negative 16. So x equals plus or minus I times 4i. And then over here, yeah, x squared equals 16. So x equals plus or minus the square root of 16, so plus or minus 4. But for this question here, all we're looking for is factor as a difference of squares. So DOS. Okay.